Hi, my name is Nicole Sinitza, and today I have the pleasure of discussing a theoretical timeline of our universe and the breakthrough ideas that went along with it. Before we begin, I'd like to ask you, what is a breakthrough? As defined by any dictionary, a breakthrough is a sudden, dramatic, and important discovery or development. However, what really is a breakthrough? In physics, a breakthrough is often an idea or a theory, something that can't be proven rather than a solid equation, a new way of looking at an old problem. And with that, we're ready to explore the timeline of our universe. Before we can fully understand what the universe is or how it behaves, I need to get off screen and give center stage to our infant universe. Oh wait, hold on. Let me zoom in a few thousand times. You probably can't see it yet. Oh, there it is. All of the mass and energy our universe will ever contain boil down into one immensely dense point. In fact, our young universe is so dense it can't handle it, and like any flustered infant, it decides to throw a giant temper tantrum. This enormous explosion is thought to have taken place 13.8 billion years ago and is known as the Big Bang Theory. What started as a suggestion by Georges Lemaitre in 1927 soon evolved into the most widely accepted universal origin theory and is responsible for the hit CBS comedy under the same name. The primordial universe was a hectic and high-energy place, composed mostly of light-density atoms, namely helium. As the process of nuclear fusion, or the combination of two atoms to create a denser element, began taking place, the building blocks for the mature universe as we know it were formed. About 200 million years after our universe's eruption, the first planets and stars began forming. This process was caused by particles sticking together as they ran into each other in the universe. As particles became bigger and bigger and accumulated more and more matter, they began to have something called gravity. As many know, gravity is the attractive force between objects of matter. Gravity was essentially the glue of our primordial universe, causing particles to attract each other, growing larger and larger until they were the size of stars or planets. Next came the formation of galaxies, such as the Milky Way, that our Earth and solar system are a part of. Fast forward to about 10 billion years after the Big Bang Theory, and we see the first superclusters, such as the Laniakea supercluster, which is the Milky Way's home. It was in 1929 that our entire view of the universe changed with Hubble's experimental data. Through Hubble's data, scientists were able to discover that galaxies and planets were actually moving away from each other. This led them to believe that our universe is actually expanding, as galaxies on all sides of the Milky Way seem to be moving away from us. This baffled many physicists, as it was a fairly common belief that our universe may be infinite. However, this was disproven with the expansion theory of the universe because an infinite thing cannot expand. At this point, theories became complicated as an infinite universe was simple and easy to back up. However, a finite universe presented issues. Many physicists argued against the theory of a finite universe, claiming that all matter would be attracted to one central point of the universe through gravity eventually. However, this was no challenge for one of modern physics' greatest minds, Stephen Hawking. Hawking suggested that the universe acted as a rubber band. It started very small and compressed in the tiny point before the Big Bang Theory. After the explosion, the universe expanded until it reached a maximum point, and then gravity began doing its work, slowly sucking all of the matter in the universe back to that one point. What you are left with is the same infinitely dense point that started off the Big Bang. Theoretically, this process would repeat over and over again, infinitely. Though this theory provides for a finite universe, In a way, in and of itself, the universe would also be infinite, as the process repeats itself over and over again. Time, too, has the potential to be infinite, as there is no limit to the number of times this process could repeat. The reality of our universe and its nature and laws may hold a very different truth than every conjecture presented by physicists. However, it is the breakthrough ideas that allow us to get closer to the truth and view the topic with more clarity.